Okay, so hopefully that's enough time to take a look at each one of those, maybe figure out a couple of those. We're going to be working on factoring trinomials today. We're going to take 2 days to cover this. We're going to cover some of the basics and then we'll throw a couple twists in tomorrow. So we need to for sure be able to multiply binomials. We've got to recognize this pattern. So I'm actually going to draw what's going on here. I'm going to multiply here and here. We've got a t squared, then a minus 5t, and then I'm going to multiply here and here. That's a minus 3t, and then a plus 15. Okay, those middle terms, whenever we have binomials that are structured like this, those are going to be like terms. We've got these 4 terms. We want to simplify them as much as possible. This is going to end up being t squared minus 8t, and then plus 15 on the end. That's what we get when we multiply those binomials. It's kind of like distributing twice and then collecting like terms. Okay, so a couple riddles here. Multiply to be positive 12, and I say the word of the sign. So multiply to be positive 12, combined to be 13. Dane? 12 and 1. That would do it, both positive. Multiply to be negative 6, combined to be negative 5. This tends to be a tough one because there's a couple different ways that you can make a 5 and a 6. D? Negative 6 and positive 1. If you tried negative 2 and negative 3, would that work? It would work on the combining portion, but they'd multiply to be a positive, so that's not going to be it. Okay, multiply to be negative 30, combined to be negative 13. A couple ways that you might think this works, but there's only one way that it works for sure. Hannah? Negative 15 and positive 2. Very good. And then the last one, multiply to be negative 40, combined to be positive 6. Multiply to be negative 40, combined to be positive 6. Colson?
10 and negative 4.
10 and negative 4. They would multiply to be a negative. They'd combine to be a positive because the bigger of the two of them is positive. Okay? So polynomials that have 3 terms are called trinomials. And we mentioned in the last section, it's very useful to be able to take a polynomial, which is a collection, a combination of a bunch of terms, and then turn it into a multiplication problem. In other words, we factor them. So remember, we talked about this yesterday. If somebody says factor something, what are they telling you to do? We talked about this yesterday. It's not fancy. If somebody says factor it, Wilson, what are they telling you to do?
Make it multiplication.
Turn it into a multiplication problem. That's all they're asking you to do. So we're going to learn to factor 2 different types of trinomials, okay? And trinomials, let's see. Okay, the trinomials that we learn to factor, they're almost all going to be quadratics, okay? Quadratic means square, so that means the highest exponent is going to be a 2. Now, we may branch out down the road to where we do something where the highest exponent is a little bit bigger than that, okay, but that's what we're going to do for right now. So we're going to categorize these 2 different ways, easy trinomials and hard trinomials. This is an easy one. This is a hard one. So here's what makes it easy. If the leading coefficient is a 1. So the squared term at the very beginning, these are written in descending order. If it's a 1, that's going to make it super easy. If it's something other than 1, that's going to make it a little bit more complicated. So that's how we're going to break these up. I've got this list of how we factor here. So again, we're only going to learn this stuff that's italicized and highlighted in red. So we're only going to be factoring 3 terms today, but the other stuff is still true. Remember, you always want to take out the GCF if you can. That's going to make it easier. Okay? I don't think we're going to run into anything with 4 terms, but we always want to make sure that we've factored completely. Okay? That's rule number 1 and rule number 5. Take out the GCF. Always make sure you factor completely and include all the factors in the final answer. Okay? And then this note right here. You can always check to make sure that you have the correct factors by multiplying and then simplifying the factors together. You don't need to do that all the time, but it's a nice idea to do it every once in a while. So here we go. Factor each polynomial or state that it's prime. Yeah, we can say that it's prime. Multiply the factors to make sure you have the right polynomial. So I'm going to zoom in on this one right here. And these are all easy ones. What makes them easy is it starts off with a plain old t squared, x squared, m squared, or whatever. So you can set up a set of parentheses, 2 sets of parentheses, and we're going to have binomials. The first ones always have to multiply to be this one. So the only way we're going to make a t squared is to have a t here and a t here. Then I've got to figure out what numbers go here and here because they've got to be plain old numbers because they multiply to be 15. and then somehow they've got to combine to be negative 8. So can you think of some numbers that multiply to be positive 15 that combine to be negative 8? Lizzie? Negative 3 and negative 5. Now let's double check here. If I were to multiply these together, I get positive 15. If I multiply the t's together, I get t squared. And if I multiply here and here, those are kind of those middle terms, I get negative 3t and I get negative 5t. Does that combine in the end to be that original polynomial up here? So do we have the right factors? We do. Okay, so I'm going to erase this. I'm going to put a box around that right here. The work down below is not required, except for the instructions said double check and make sure that you've got it right by multiplying through. Got a question for you. Let's say I looked at Andy's paper and Andy had a negative 5 right here and a negative 3 right here. Is that okay? It is. Because this is basically a t minus 5 written first and a t minus 3 written second, so that's totally all right. Everybody good there? Okay. Easy trinomial because it starts off with a 1x squared, so set of parentheses. The only way to make an x squared is to have an x here and an x here, and then we have to ask ourselves this question, that riddle question. I need some numbers that multiply to be negative 12, but they combine to be positive 4. Multiply to be negative 12, combine to be positive 4. We want to be pretty quick at these. The faster we are at these, the better. Sai?
6 and negative 2.
Okay, now you mean positive 6, right?
Yeah.
Okay, positive 6 and negative 2. Let's double check. X times x is x squared. X times negative 2 would be negative 2x. The 6 times the x would be 6x, and the 6 times the negative 2 would be the negative 12. These two are really the important double check right here. That's going to be 4x right here. So we do get back to the original polynomial at the beginning. So this right here is the answer. So the cool thing about this is kind of a riddle method. Some people call this guess and check. If you know for a fact that they multiply to be this number and combine to be the coefficient in the middle, along with the signs and stuff like that, you don't always have to double check. Okay, let's take a look at this one. Easy trinomial because it starts off with a 1x squared. Got to have some numbers that multiply to be negative 6, combine to be negative 5. Wait a minute, does this sound a little familiar? Mm-hmm. Lizzie, what is it? Negative 6 and positive 1. There we go. That's going to do it. Okay, if you want to run through the double check there, you're welcome to. These are going to multiply to be x squared. These are going to multiply to be negative 6. It's really these that we're interested in. Do they work out to be that correct middle term there? Whoops, this is a negative 6 plus 1x. So negative 6x plus 1x, it's going to work out to be a negative 5x. Okay, Megan, what do you think about D? It's got an asterisk by it.
I don't know.
I appreciate the honesty. What's weird about this, Megan? It's cubed. It's got a cube on it. I told you we'd only have squares, right? We'd only be doing quadratics. Colson, what do you think?
You can take out one x and all.
You can take an x out of all of them. So if I take an x out of all of them, that turns it into an x squared, a minus 7x, and then a minus 30. There's no x left on that last one. Caleb, is this an easy trinomial to factor now? What makes it easy? There's a 1 in front of the x squared. So I'm going to write the set of parentheses here. The only way to make that is an x and an x. Lydia, I might forget something if I don't write it down right now. What might I forget? The x. I'm going to bring that down there so I don't forget that. I've got to include that so that it's completely factored. And then I need two numbers that multiply to be negative 30, combined to be negative 7. Multiply to be negative 30, combined to be negative 7. So let's see. 5 and 6 would make a 30, but you can't make a 7 out of those. Maybe a 1 and a 30. Can't make a 7 out of those. Zach?
A negative 10 and a 3.
A negative 10 and a positive 3.
Let's go with that.
Okay? We good? Multiply to be negative 10x. Multiply to be plus 3x. Those would combine to be negative 7x. I need everybody's eyes up here. Do not write this. Everybody eyes up here. Okay. What if somebody did this? Jack, what do you think?
No,
Why not?
because then it wouldn't be -7.
Very good. They still multiply to be -30, but they combine to be +7, not -7. So we'd want to be careful with something like that, okay? You got to double check. Would it be okay if we wrote the x plus 3, then the x minus 10? That's okay. That's just the commutative property like we were talking about. Okay, any questions? We good? Raise your hand if you've seen stuff like that before. A couple of you. I think actually everybody did the end of last year in secondary 1 math, okay? All right, so the two at the bottom of the screen, these are hard trinomials, okay? Here's what makes them hard. They start off with something other than a plain old 1x squared. So this is more difficult. You might look at this and say, hey, maybe we can factor something out. We can't. Maybe we can factor something out. We can't. So this is one technique. This is not the technique that I was taught when I was a kid. So I'm 52. This was probably 35, nearly 40 years ago. Okay. They just said, hey, guess and check. Just get good at guess and check. And then I learned this about, I don't know, 10 or 12 years ago. And I thought, my gosh, why would I want to guess and check when I can know for a fact that it factors or that it's prime? And if it does factor, I know I'm going to get the answer right every single time. Okay. So this is called trinomial grouping. You'll hear people call it a bunch of different things, but we use that for hard trinomials. So if it starts off with something other than a 1x squared, we're going to use this technique. So it's got this list of things and steps that you can go through, okay? But we're going to do this. So let me just show you how this works. We're going to multiply the leading coefficient with the constant at the end, including the signs. So this is why I'm a big fan of saying positives and negatives and stuff like that. This is +2 times +6. They multiply to be +12. I then ask myself the exact same question. I want numbers that multiply to be +12 that combine to be +13. So this is the way my mind works, but we're going to change this into a problem that we already know how to do. 2 times 6, +2 times +6 is +12. Then I stare at that number, I write it down, and I think of the sign if I'm not going to write it. And then I look at the 13 and I think to myself, can I find numbers that multiply to be 12 that combine to be +13? Yeah.
+1 and
+1 and +12. Okay, now, please double check yourself right here. Do they multiply to be +12? Yes. Do they combine to be +13?
Yes.
Yes. If you can find answers to that riddle, you are guaranteed that as long as you don't make any silly mistakes, number one, this is not prime. It will factor, and you're going to get the factors right. So here's how it works. We're going to take this, and we're going to rewrite that middle term using those two numbers. 2x squared plus 1x plus 12x plus 6. Abby, how many terms do I have now? We have 4 terms, okay? Angela, if we've got 4 terms, what did we learn yesterday? What technique do we use? Grouping. So I'm going to group these two together and these two together. So I can take out an x. I'm left with a 2x. Oh, I took everything out, so nothing's left. I'm not going to write anything.
1.
What am I going to write? Thanks, Wilson. I'm going to write a 1. What can I take out of a 12x and a 6x? Mason? I'm going to take out a +6. I'm going to write that +6 because that sign's really important. What's left here is a 2 and an x and a 1. I've gone from 4 ugly terms to 2 kind of ugly terms, but they have something nice in common. Luke, what do they have?
They're the same.
They have the same factor right here. So they both have a 2x plus 1. So I'm going to take out the 2x plus 1. I like putting it out front. You're welcome to put it at the end if you want. And then I have an x plus 6. So I'm going to put a circle around that. That is the correct answer. Little harder, but it works every single time. Okay. I'm not going to ask if there's any questions about this technique because I'm sure there are. Here's the first one that people usually ask. You don't need to write this down. I'm going to change colors. Everybody watch. They say, hey, Mr. Laws, what if I wrote down 12x first and then I wrote the x second? So watch. 2x squared plus 12x, because that's what came out of my brain first, so I just wrote it down. Let's group the two of those together and the two of those together. I can take out a 2 and an x. I'm left with an x and a plus 6. What can I take out of there? Nothing, but I've got to take something out. So I'm going to take out a 1, and I'm going to write the sign of that 1 that I take out. Taking out a 1 doesn't change anything, but now I've got an x plus 6 in both of them. And with that one, I'm left with a 2x, and with that one, I'm left with a plus 1. So I get the same answer either way. Does it matter that the 2x plus 1 came second on this one? I'll pause for applause. I didn't invent this. There are lots of different ways to explain this, but does it make any difference which order you put those in?
No.
It doesn't. As long as you answer this question correctly and you're sure you've got it right, not only do we know it factors, we know if we're careful we're going to get it right, okay? So if you make sure that you've got the right answers, you know you're going to get it right, and you know if there is no answer, like if you can't answer that riddle, there's no answer to that riddle, then you know for a fact that it's prime. You don't have to spend 20 minutes guessing and checking all the different possibilities to see whether or not it works, okay? All right, everybody good? Okay, here's the technique again. Leading coefficient and constant, multiply them together. With the sign, that's positive 36. I need numbers that multiply to be positive 36, that combine to be negative 13. Do not say anything out loud. 36 and 6, for some reason, because there's so many combinations that make those numbers, those tend to be some of the toughest. So think for a second. I need some numbers that multiply to be positive 36, combined to be negative 13. And I'm a big fan of saying the sign of the numbers that we're working with. So let me say it one more time, and then I'll ask for a volunteer. Multiply to be positive 36, combined to be negative 13. What can you tell me about the signs of the numbers? If they multiply to be a positive and combine to be a negative, what can you tell me about the signs of the numbers? Hannah? Both of them have to be negative. Zach, do you know what the numbers are?
It would be -4 and -9.
-4 and -9. Does that work?
Yeah.
Now, does it matter? He said -4 and -9. I wrote -9 and -4. Does that make any difference? Nope, doesn't make any difference. Stop for a sec. Watch. Do they multiply to be positive 36? Yes. Do they combine to be negative 13?
Yes.
Yes. We're going to get the answer right. We know it for a fact. All we have to do is be careful. So we're going to write down 6q squared minus 9q minus 4q plus 6. Group, group. 6 and 9, that's a 3. Q squared and q, I can take out a 3q. I'm left with a 2q. 2q, if I take out a 3q out of a negative 9q, what am I left with? Crew?
6.
No.
Wait. 3.
3, because we're not subtracting out. Remember, we're dividing out. So this is going to be a -3. Okay? Then I look at the last guys right here. This second group is a -4q plus 6. Andy, what are we going to take out?
2.
He is right about the 2. Kind of. What did you say? -2. And we want to indicate that we're taking out a negative. Remember, the word negative means opposite. So what's going to happen here is what used to be negative here is going to turn into a positive. That's a positive 2q. What used to be positive is going to turn into a negative. That's a -3. And at this point, we're feeling really good about ourselves. Why are we feeling really good about ourselves in this process? What looks good here? Mason?
Well, you have the same factors on the inside.
We have the same factor. We have a common factor. We've only got 2 terms left, and we've got a common factor. So 2q minus 3 and 3q minus 2. There's the answer. Okay, any questions? Okay, raise your hand if you've seen that before. Just a couple of you. Okay. You can use, so here's all this paragraph says at the top here. You can use a guess and check technique on hard trinomials if you want. If you get really, really, really good at it, you might be faster than that trinomial grouping technique that I just showed you. I've taught hundreds and hundreds of students this. I've run into maybe one or two that can do it faster than that. Okay. And if I throw them a really tough one, like with a 36 and a 13 or something like that, it usually works out. And here's the kicker. If it's prime, they can spend 5 minutes and you can be done and know that it's prime in just a couple of seconds. Okay. All right. So let's take a look at this one right here. Just a couple more. We're going to multiply. Looks like it shouldn't be very hard. Multiply to be positive 4. Combine to be 3. Multiply to be positive 4. Combine to be 3. If I'm trying this, I've got a 1 and a 4. Any way to make a 3 out of those? Wait a second. You could make a 3 out of them if this one was negative, right? But then they don't multiply to be a positive, so that's not going to work. 2 and a 2? No way. So? Prime.
That's funny too.
Okay.
0 and 4.
Megan, take a look at B. What do you notice? There's the cube again. So what are we going to do? First thing we're going to do is we're going to take the x out. That's always going to make our life easier. So we're going to take out the x. There's nothing else I can take out. So this is going to be 6x squared minus 7x and then minus a 20. My gosh, that looks horrible. Might want to grab a calculator for this one. 6 times negative 20 is negative 120. So I'm looking for this. 2 numbers that multiply to be negative 120 that combine to be negative 7.
Oh.
1 and 120? Nope. 2 and 60? Hang on. Nope. 3 and 40? Nope. 4 goes in there 30 times. 5 goes in there 24 times. Is that right? Okay, we're getting a little closer because these are the difference between the two of these is 121. The difference between the two of these is 19. I need the difference to be a 7. So if we kept going, 6 goes in there. Does 7 go in there? No. 6 and 20. 7 doesn't go in there. 8 and? Ooh, oddly enough, 8 and 15. Can you make a 7 out of an 8 and a 15? You can. Okay. Now, I'll show you a way that you can use technology to help you out just a little bit. I'm going to have Wilson. We are going to use an 8 and a 15. But what signs do they have?
Negative 15.
Very good. The bigger one's got to be negative because they have to combine to be a negative. So this is going to be a 6x squared. I'm going to write plus 8x minus 15x minus 20. And then we're going to keep going with this. I can take out a 2 and an x. If I take out a 2, I'm dividing out, remember, so that's going to be left with a 3x. Dividing out, so I'm going to be left with a 4. Colson, what can I take out of these two?
Negative 5.
Ooh, he got it. Negative 5. Take out the negative. We're left with a 3x and a plus 4. At this point, we're feeling really good because we see that common factor right here and right here. So I'm going to write 3x plus 4. Then I'm going to write down the 2x minus 5 right here. I'm going to circle it, aren't I, Dane?
Wait, no.
Why not?
Because you can. Oh, yeah, you put an X in the.
Yeah, I don't want to forget this guy right here. If you don't put that factor that we pulled out in step number 1, taking out the GCF, then we got trouble. Okay? All right, any questions? Yeah.
I'd just like to point out that if you need some help, you can actually really easily make a table with numbers that go into.
Okay, you keep that to yourself. That's the technology help we're going to talk about next time. Most of the time you won't need it because the numbers aren't going to be very big. Okay? All right. Do C. Go ahead and do C.
Oh, okay.
Raise your hand if you're done. Ooh, nice. Look, you were done?
I got the numbers.
Well, but you're not done, right? I mean, factors written down. Okay, stop. 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 Sai, what's rule number 1?
Take out the greatest common factor.
That's what I did.
If you take out the GCF of 6, what does it turn the trinomial into? An easy trinomial. Now, if you wanted to take 6 and negative 120 and multiply them together, that's negative 720. If you want to find numbers that multiply to be negative 720 and combine to be negative 6, you will find them. They're huge, but isn't it, you did? Amazing. Isn't it much easier to follow rule number 1? Taking out the GCF is always going to make your life easier. I've got one more thing I want to point out, and then I'll show you the assignment. Watch. Watch, watch, watch. Trinomial grouping actually works on easy ones too, because the number in front is a 1. So if I take the coefficient in the front and multiply it by this one, I get a 15. Multiply to be 15, combine to be positive 8. I'm going to use a 3 and a 5. Negative 3 and negative 5. So this is going to be a t squared, quiet please, minus 3t minus 5t plus 15. Take out a t minus 3. Take out a negative 5, you'd be left with a t, and if I take a negative out of a positive, it turns it into a negative. So there's a t minus 3, and there's a t minus 5. Same answer we got earlier. That technique works. And the cool thing about math is if you've got a technique that works, if you've got an algorithm that goes through and gets you the answer every single time, it should work on easy ones and it should work on hard ones. Okay, any questions?
I'm blind.
Why on C did you do with no word? He just had the answer. I was like, what?
Say that again?
Yeah, it didn't like show any words on C.
I did. You're right. I did. You mean I didn't show any work on this one?
Yeah.
Why didn't I need to? Why didn't I need to? No. There's a reason for it. Somebody raise their hand and tell us, why did I not have to show any work on this? Lizzie. It turned into an easy trinomial. Do we have to show any work on easy trinomials? No, we find numbers that multiply to be negative 20 and combine to be negative 1. That would be negative 5 and positive 4, and that'll be it. Okay? So it wasn't a trick, it was just following the rules. All right.
Following the rules is a trick.